or where is the y-intercept of this graph? Good, -3. 0, -3. Perfect. Where are the x-intercepts? Good, -3 and +1. And if I write it as a coordinate point, just remember that the y-intercept is 0, comma, whatever, and the x-intercept is going to be the number, comma, 0. So this is -3, comma, 0, and 1, comma, 0. Beautiful. All right, where's my vertex? Good, Guillermo, nice job. Remember that when you give me the vertex, it's very important that you give me the full coordinate point.
Oh,
So,
I missed the vertex. I didn't even see it.
oops, that's okay. So remember, it's -1, comma, -4. You got to give me both numbers so that I know exactly where it is. Okay, so those are kind of the three big, really important ones. And now for axis of symmetry and then maximum and minimum, there's just a couple little things we have to remember. So axis of symmetry, what's that one going to be?
-1.
-1, but let's be a little more specific. So it's at -1, but how do I write the full answer?
X equals -1.
Yeah, you have to write the letter X, because if you just say -1, I don't know which -1 you're talking about. There's a -1 over here, and there's also a -1 on the y-axis. So you got to just be very explicit. X equals -1. And then finally, my max, is it a maximum or is it a minimum?
Minimum.
It's a minimum. And where is that one?
-4.
And again, we're going to be very specific.
Y equals -4.
Yeah. Because just like the axis of symmetry, the minimum in this case passes through the -4, but that's the -4 on the y-axis. So that's why we have to make sure for axis of symmetry, we write x equals -1. For maximum and minimum, we write y equals whatever it is, -4. So this is kind of like the basics. I just want to make sure we all understand this. Does anyone have any questions? Cool. All right. So we're going to start with topic 8. Topic 8 is like the math. You guys really like topic 8. It's foiling, multiplying polynomials, adding polynomials, subtracting polynomials. It's all just very math, okay? Topic 9 is when we have all the graphs and the word problems and the functions and all of that. So topic 8 review should be pretty quick. We'll get through it as quickly as we can. And then once we get to topic 9, that might take a little bit longer. So let's just go ahead and start with topic 8.
I have a question.
Yes, question.
Did we do the topic for like the radicals and stuff?
That was in the previous test. We already passed that.
Really? I thought we were. Oh, wow.
Nope, that was topic
Spring
7.
really did something to us.
Yeah, spring break really like knocks you out. All right. Oh, hold on. I want to answer a question from the chat. Somebody asked, are the axis and the minimum and maximum always opposite? So like in this case, one of them is the x and the other one is y. Yes. So that's a really good point. Axis of symmetry is always going to be x equals whatever. The maximum and minimum is always going to be y equals whatever. So this one's always x, and then this one's always y, always. And then that's the only really thing you have to remember. The other way you can remember it is if you actually draw the axis of symmetry, right? Look at my orange line. My orange line passes through the -1 on the x-axis. If you look at my blue line, the blue line passes through the -4 on the y-axis. So if you forget which one it is, it might be really helpful to actually draw it. And then someone's asking for the minimum, you don't have to write the full coordinate point. No, for the minimum, you just write the y value. For the axis of symmetry, you just write the x value. All right, any other questions on that? Awesome. All right, let's get into it. So polynomials. Topic 8 is all about polynomials, adding polynomials, subtracting polynomials, multiplying polynomials, but also identifying polynomials. And kind of, you got to remember what is a polynomial and what is not a polynomial. So we've actually seen this question before a while back. But let's start looking through it and let's identify which of these is not a polynomial and why. So does anybody see one of these answer choices that's definitely not a polynomial?
B?
B and A, yeah. So let's start with B. What's wrong with B?
It has an exponent as it has a decimal as an exponent.
Good. So exponents can't be decimals. Cool. And a couple people said A. What's wrong with A? Yeah, there's
The exponent is a fraction.
There's a fraction, and the most important thing, fractions aren't always bad, but what's wrong about this one? Yeah, where is the R located? Down in the bottom. So variables can't be in the denominator. Okay, these are kind of, I'm going for the rules for polynomials. So these are the rules. Variables can't be in the denominator. Exponents can't be decimals. And there's one more that's wrong. So look carefully between C and D. See if you notice something fishy.
Is it C because of the negative?
Yeah. Good. So let me just circle all the things here. Okay. So that's the last rule. Exponents can't be negative either. Okay. So these three are all breaking the rules of polynomials. The only one that's actually correct is D. And even though D has a fraction, it's totally okay because the variable is in the numerator, not the denominator. So that one's fine. So does anybody have any questions on how to make sure you know what is a polynomial and what is not a polynomial? Those are the three rules. I highly suggest you either take a picture of this slide or you write this down. This is something very, very useful to study from. Good. So question in the chat, fractions aren't always bad. No, they're not. They're not always bad. The only time where a fraction is going to be bad or it's going to be a problem is when it has a variable in the denominator. As long as the variable's in the numerator, you're totally fine. And the reason for that is that we can actually rewrite this as 1/8, oops, 1/8 x. So the fraction is just a coefficient. It's just a coefficient. It's nothing crazy. But over here, since the denominator has a variable in it, that actually means that it has a negative exponent. And we already know that negative exponents don't work out. All right, any other questions? Awesome. Anybody else still writing? Okay, cool. Oh, one person's still writing. Go ahead, take your time. Take your time. And while we have students who are finishing up, If anyone else has any other questions, now's a good time as well. All right, take about 15 more seconds. Alrighty. All right, moving on. So like I said, topic 8 is all about adding and subtracting and multiplying. So let's go ahead and start with subtraction. Now, if a question looks like this, it's telling you to subtract this trinomial from this trinomial. What do we have to remember to do?
We have to do the opposite, like 8b, the second expression 1st.
Yeah, the second expression, we write it down first. So it's this guy minus that guy, because we're taking this one away from the second one. So really, you got to make sure that if you see a problem like this, you read it carefully and you have it in the correct order. Okay, so again, I'm taking this away from this. So I have 8b cubed minus 6 plus 3b to the power of 4 minus b to the power of 4 minus 7b cubed minus 3. Well, now I have subtraction. So what's the other thing we have to remember to do?
We have to make the exponent to the right negative. I mean positive, because they're already negative, but the b4 is going to be negative as well.
Okay, so in other words, anything that was negative, it turns positive. Anything that was positive, it turns negative. And that's because we have to distribute our subtraction sign. So anytime you're subtracting, this only happens for subtraction, you have to distribute the subtraction sign. And all that does is it flips all the signs. So this one stays exactly the same. But now I'm switching everything. So I have minus b to the power of 4 plus 7b to the power of 3 plus 3. So I'm just flipping everything. And now I can just combine all my like terms. So can anyone give me one pair of like terms?
The 3 exponent 4 and negative b4. And 8b cubed and 7b cubed.
Good. And then obviously we also have our constants. So -6 and +3. All right, we're just going to go ahead and combine everything. I'm just going to go from left to right, and then we'll rearrange everything afterwards. So 8b cubed and 7b cubed, what do I get? What operation am I using? Am I adding or am I subtracting?
Adding, will it be 16b cubed?
Not 16.
Oh,
15, yeah. So just be careful, Juan, because this is a plus sign here, because we had to flip it, remember? So we're adding. What about, okay, -6 and +3? -6 plus 3, good, -3. And then finally, 3 minus b, 3 minus 1.
2b.
2b. Cool. So is this it? Is this my final answer? Am I done?
No.
Yeah, what should I do now?
Standard form?
Yeah, good. So remind me, what is standard form?
Where you put the greatest exponent in the front.
Good. And it goes from there. So what's the greatest exponent is 4. So 2b to the power of 4 goes first. What comes next?
Positive 15b cubed.
And then finally,
Negative 3.
and that's our answer. So there's two ways that you could do this. I kind of just combined like terms going from left to right in whatever order it was in, and then I turned it into standard form. But you could have also looked at this large polynomial, and then when you combine like terms, you could automatically do it in order. So you could have done the exponent of 4 first, and then the exponent of 3, and then the constants. But either way, you end up with the same answer. So it doesn't really matter which way you do it. But the most important thing is to make sure your final answer is in standard form, which just means that the largest exponent goes first, and then the exponents go in decreasing order. So take a moment, see if you have any questions, and then we'll move on to the next one. Oh, my bad. There we go. Any questions? Awesome. All right, so that was subtraction. Now let's take a look at a similar kind of problem. We've actually seen this one before. So this one is telling me that P of x equals x squared plus 2x minus 5, and Q of x equals x minus 3. And then it's telling me to do P of x minus Q of x. So what am I doing? What is this actually just telling me to do?
Put it together.
What operation am I going to use?
A subtraction.
I'm subtracting, yeah. So this question makes it look hard because we've got like P of x and we've got Q of x, and those always look confusing, but it's just telling you to take P of x and subtract it minus Q of x. So there's P of x, there's Q of x. I'm just subtracting. So x squared plus 2x minus 5 minus x minus 3. And we're just going to follow the same 3 steps. So first thing, I'm just going to distribute my negative. So I have negative x, positive 3. And now I just combine like terms. So take about 1 minute on your own and go from here. Combine like terms and give me your final answers in standard form. Okay, just about 10 more seconds. And time. All right, combining like terms, I have 2x and negative x. And then I also have negative 5 and positive 3. What is my final answer going to be once I combine everything? Final answer. Who wants to share?
X squared plus X -8.
X squared plus X, really close, not -8, but we have a -5 and +3.
I didn't see the +3. It was -2.
-2, there you go. Good, guys. I see a lot of correct answers in the chat. All right, so questions on this one? Any questions at all? So this is kind of how we'd subtract. We should feel pretty good about subtraction at this point. Questions? Awesome. All right. Next up, this time I have a word problem. Again, we have seen this one before. This is why with our reviews, I'm kind of bringing up older questions to just make sure we still remember how to do it. So who can read our word problem? Who haven't I heard from in a bit? Who's feeling up for it? First day back from break. How about, let's see, who's at home?
I'll read.
Oh, okay, go ahead.
Triangle has side lengths of 5a plus 3 inches and 2a plus 3 inches. The perimeter of the triangle is 9a plus 12 inches. Which expression represents the length in inches of the third side of the triangle?
All right, so it's a word problem and it's describing a triangle. So what do you guys think? What would be a really good thing to do in order to visualize it a little bit better?
Draw it out.
Draw it out. I have a triangle. I'm just going to draw a quick little triangle. And it's telling me that, okay, one of the side lengths is 5a plus 3. The other one is 2a plus 3. And the perimeter is 9a plus 12. Now, what am I missing?
Wait, wasn't this somewhere before, like on a
Yeah, we've seen it before. What am I missing in this scenario? Yeah, I'm missing the third side. I know the total, I know the perimeter, but I don't know this third side. That's a question mark. So, okay, what is the perimeter of a triangle? If you can describe, what is the perimeter of something?
What's on the outside?
Yeah, it's the sum of all the sides, right? So right now I only know 2 out of the 3 sides, but I know that they add up to 9a plus 12. So what's one strategy for how I can figure out the missing side?
We add the side lengths and then we subtract it from the perimeter?
Exactly. So we're going to add up the 2 side lengths that we already know, and then we're going to take that away from 9a plus 12. So let's start by adding these up. So I have 5a plus 3 plus 2a plus 3. Since I'm adding, do I need to switch any sides or distribute any negatives or anything like that?
No.
Nope, we're just gonna add it straight across. So I'm combining like terms. What are my like terms?
Everything
What do you mean?
5a and 2a
Mm-hmm.
and 3, 3.
3 and 3. So in total, what do I have?
7a plus 6.
7a plus 6. Okay, so I have, make this purple. I have 7a plus 6 is what I already know. So I have two of the three sides are 7a plus 6. The total is 9a plus 12. So to get my missing side, I'm going to take the perimeter and I'm going to subtract the side lengths. So I'm doing 9a plus 12 minus 7a plus 6. So go ahead and take about a minute to subtract on your own, see what you get, and then we'll go through the final answer. 1 minute. Okay, about 15 more seconds. And time. All right, this is just like all the other problems we've already done, so I'm going to go through it pretty quickly, but it's subtracting, so I know that I need to distribute my negative. So I have 9a plus 12 minus 7a minus 6. And then I'm just combining like terms. So I have 9a minus 7a. What do I get? What do I get? 9a minus 7a? 9 minus 7? Nine minus 7? Anyone? No one?
2.
2. 2a.
A.
Yeah, a. Just a. Not a squared, not a to the power of 3. These don't have any exponents on them. So the final answer doesn't have any exponents either. And then finally, 12 minus 6 is 6. So 2a plus 6. Final answer. That's my missing side. Questions on this one? This one was a little more challenging because it was a word problem and you kind of had to work it out. But at the end of the day, we were adding at first, and then we were subtracting. So we're still just doing the same operations of addition and subtraction. Any questions? Okay, so somebody's asking about the exponents. Remember, when you add and when you subtract, you're just combining like terms. That's all you're doing. It's like you have 3 pens over here and 2 pens over there. So when you put them all together, you got 5 pens. Do these pens magically get exponents on top?
No.
No, we're just combining like terms. So don't get fooled. Don't make that little mistake. A lot of times people forget that when you add and subtract, you don't get exponents. That's only when you're multiplying. So I have 9 A's over here. I have negative 7 A's over there. When I put them together, I only have 2 A's. They're not going to have an exponent because we're not multiplying. We're just adding and subtracting. So that's the big difference. Combining like terms doesn't change the exponent of the numbers. Questions on that? Cool. All right, I had a request to go back to take a screenshot. So I'm just going back to this page real quick so that that student can take their screenshot and then we'll move on. All right, cool. And then 10 seconds here in case anybody else would like to take a screenshot of that. All righty. Okay, now we're moving on to multiplication. So we went over subtraction, we went over addition, we did a couple word problems. Now let's multiply. So I have two binomials. I'm multiplying them. What is that strategy that I should be using?
FOIL.
Yeah, we are going to FOIL this binomial. Okay, anytime you have two binomials, just like this, two binomials, multiplying them, we can FOIL. So we start out, what does F stand for? What does the F in FOIL stand for?
Forward. No, front.
Close, not front, although that's a pretty good one. First, yeah. So that just means you're looking at the first two terms. The first term of this binomial is 2x squared. The first term of that binomial is x. And we're just going to multiply those together. So what's 2x squared times x?
2x cubed.
2x cubed. So that is when we are going to change the exponent. Since I'm multiplying, okay, since I'm multiplying, not adding, not subtracting, but multiplying, we are going to add the exponents to get 3. So that's the big, big difference you have to remember. Once you start multiplying, you got to add those exponents. So that's first, what does O stand for? What's O? Good, outside. Outside, so that's 2x squared and -2. It's like a sandwich. You pick the two numbers on the outside. So what's 2x squared times -2?
-4x squared.
Good, you got it. -4x squared. Then what is I?
Inside.
Inside. Good. Which ones are my inside terms?
6.
6 and?
X.
Good. Like the sandwich, it's your peanut butter and your jelly. So what's 6 times x?
6x.
And then finally, L. Good, I'm seeing it in the chat. Stands for last. So that's everything that's left. 6 and -2. What's 6 times -2? -12. Good.
12.
So there we got our. Now, do I have any like terms? Any like terms?
No.
No. Good. So that's it. That's my final. If you have like terms, you can combine them. But in this case, there are no like terms. So we leave it. Remind me, what makes something a like term? They have to have the two. There's two things that they have to have the same.
Same variable and the same.
Good. Same variable or variables. And same exponents. So when you look at these numbers, none of them match. there's x to the power of 3, x to the power of 2, x to the power of 1, technically, and then 12. So none of them are like terms because none of them have the same exact exponents. Alrighty, so any questions on foiling? Any questions on combining like terms? Anything at all on this question? Okay, so someone's asking, what if you add them? So in this case, okay, let me actually make something very clear. I have 2x squared plus 6 in parentheses, and I have x minus 2 in parentheses, right? And there's nothing in between them. So in this case, I know that I'm multiplying because I just have the two binomials right up next to each other, and parentheses tell me to multiply. But what if it looked like this? What if it was like, what am I doing in this case?
That's when you add.
That's when you add. So you have to be very careful. And let's see if I have another example. No, not really. But you have to just make sure you look carefully. In this case, I would be adding because I have a plus sign in between them, separating them. But here, there's no plus sign, so I know that I'm multiplying them. So would I get the same answer or a different answer in this case?
It's just like x, like there's an invisible 1 in front of the x, while when you have of expression, there's a time stamp thing.
Yeah, there's like a little invisible multiplication sign. So in this case, you would end up with a completely different answer because when you add things, that's just different than when you multiply. Here, let's just do it really quickly. You would end up with 2x squared plus x plus 4. So you end up with a completely different answer if you're adding compared to if you're multiplying. So definitely very important to just make sure with a question like this, you just make sure, read it twice. Always read questions twice, just to make sure that you read it correctly. Questions on that? All right, cool. Let's do another one. How about in this case? What is this telling me to do?
Multiply.
And very specifically, what exactly am I multiplying?
3x plus 6.
Times what?
Times itself.
Times itself. Okay, good. So remember that if you have an exponent like this is telling me to multiply times itself. So I can rewrite this as 3x plus 6 times 3x plus 6. So go ahead and take a minute to FOIL on your own, and then we'll compare our answers at the end. Okay, 15 seconds remaining. actually, I'm going to wait a minute more because I want everyone to really try. I want to see your answers in the chat. So far, I haven't seen any correct answers. So I'm still waiting. Still haven't seen any correct answers. Keep trying, guys. All right, there we go. There we go. All right, now I'm getting some correct answers. So let's try this together. So I have about 3 students who got it right and a lot of students who did not. So I definitely need to make sure that we understand this. So let's take a look. Those of you who, if I replied to you and I told you that you got it right, which I think I did to everybody. Hold on, one more person. There we go. Then I want you to help me out while I explain it. So make sure you put your answers publicly in the chat if you know that you got it right. So first things first, what am I multiplying first? When I FOIL, what goes first? 3x times 3x. 3x times 3x, what does that give me? Be very careful. There you go, 9x to the power of 2. If you forgot that exponent, then your final answer, you got it completely wrong because this exponent is super, super important. Where does it come from? How come this is a 2?
Oh, I added. I did put the exponent, but I added.
Okay, but how do you get this 2 right here?
Oh, since it has the variables, there's like a exponent on the on top of the variable. So since we're multiplying, this goes back to the topic that we reviewed before. X1 times x1, you have to add the exponents together.
Exactly. And Raymond said it as well. You add the invisible exponents. So if it helps you to just put those invisible little ones, put them down because it might remind you to add. So remember that anytime there's an x that's all by itself, it has an invisible exponent. So we get 9x to the power of 2. And that's going to change a lot of your answers. Okay, after that, my outside terms, which ones am I multiplying now? Good, 3x times 6. 3 times 6, what do I get?
18.
All right, that's outside. What about inside?
6 times 3x.
6 times 3x. So what do I get there?
18x.
Also 18x. And then finally,
6 times 6.
which gives me
36.
36. So thank you and good job to Raymond, Alyssa, and Ijara for getting the correct answer. Now, those of you who made a mistake, please, right now, it is super, super important that you write it all down so that you make sure you know how to do it next time and that you ask me any questions that you have as we're going through it. Now there's one last step. What happens now? Good, Karina. I have like terms. How many like terms do I have?
2.
Just 2, just these guys right here. If you forgot about this exponent in the beginning, you might have accidentally combined all 3. But this 9x squared is not a like term, only the 18x's are. So our final answer is 9x squared. 18 plus 18, I get when I combine like terms, what do I get?
36x.
36x. And then plus 36. And that is my final answer. So those of you who made a mistake or maybe just didn't do it properly, go ahead, look through it one more time and ask me right now. This is your final chance to ask me any questions. You forgot about the 6's. Okay, so you only did, you foiled, you didn't foil. Yep, okay, so that's why it also helps if it helps you to write it out and just make sure, cross it off as you go. Did you do all 4? Just make sure that you did all 4. Any questions at all? All right. I'm going to go back to the previous slide again, just because someone else wanted me to go back to it for a moment. So go ahead. And that was our last problem for topic 8. So now we're going to go ahead and move on to topic 9, which is all about functions. So adding, subtracting, and multiplying, this is it. All righty. Okay, here we go. Transforming quadratic functions. So let's take a look at this problem and let's just start refreshing our memory about how this works. So the original function, f of x equals 2x squared minus 1, is shifted to the left 3 units to make g of x. Which expression would represent g of x? So take a look at the answer choices. Let's just do a quick poll and see how we're doing as of right now, and then we'll go over it. Go ahead. Take 30 seconds. All right, get your answers in the poll. Pick your best guess in 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. All righty. So just what I expected. We are kind of even between A and B, so we definitely need to review this. And then I had a couple people choose D. I know why you chose D, but let's go over why that one's also wrong. So A or B? This is one of those things that people just always make the same mistake. A or B, which is B, gang. Okay, all right, so we're feeling good about B. Why? Why would it be B and not A? Let's hear it. So y'all you feel good about B, but can you explain why? Yeah, okay, Lauren's got it. So remember, and this is something that like if you keep making the same mistake over and over, this is your chance right now. Right now, you got to get it into your head so you don't make the same mistake again. When you go to the left, you're going to see a plus sign. When you go to the right, that's when you would see a minus sign. So it is B. It is B. So let me just make sure that we understand the difference. What would A be doing?
Going to the right.
Yeah, this would be to the right 3 units. That would be to the right, because this minus sign in here, you have to flip it. You have to remember to flip it. This one has a plus sign, so that's left. And I did have a couple people choose D, so let's check this one out. What's happening here? Originally, this was a -1. Now it's a -4. What's happening there?
It's subtracted.
It went, yeah, it subtracted 3. So what direction did that go?
Down.
Down. And how about this one? This is +2.
Up.
That went up. Yeah.
Well, this was in the packet, right?
I think this one was, yeah.
When
Yeah.
I thought, I was really, really confused. I don't know. Maybe it was just my mind. And I did it yesterday too. So
Mhm.
trying to rush.
That's okay. That's okay. It's good to just get a little bit of a refresher on this. So the biggest thing to remember is that inside of the parentheses goes right and left. And if you're going to the left, you're going to have a plus sign. If you're going to the right, you're going to have a minus sign. So we'll review. I think I have one more question about this, but does anyone have any questions about it? Okay. I think I have one more. Yes. So let's try this one. I'm interested in seeing what people think. So I'll read it first and then I'll launch the poll. The graph of g of x equals x squared was transformed to create the graph of h of x equals -1/4 x to the power of 2. Which of these describes the transformation from the graph of g to the graph of h? Try this one. And again, I'll give you guys about a minute. $15 more seconds. Take your best guess. Go with your gut. All right, get them in 5, 4, 3, 2, and 1. Let's see what we got. All right, this one is a little bit more all over the place. I'll show you guys what the results look like. If it loads, there we go. Okay, so kind of everywhere, right? We got a few people for A, a few people for B, C1, but barely. And then we definitely don't like D. So let's take a look. All right, so first of all, what are the differences? To go from g of x to h of x, we have a -1/4 in the front. So what does the negative do?
Reflect it.
It reflects it. But now this is where we have to remember, is it reflecting over the x-axis or the y-axis?
X-axis?
Do we agree? Do we disagree? What do we think? It is a reflection. And okay, I'm seeing some agreement in the, yeah, it is over the x-axis, not the y-axis. So C and D are automatically out. It's a reflection over the x-axis. And that's just, let me explain why. That's because normally a parabola looks like this. It's a happy face. Here's my x-axis. When you have a negative sign, that parabola is going to flip. But which direction is it going to flip?
Down.
It goes down, right? So when it goes down, it's flipping over. You can think of it like the x-axis is like a line in the sand. You're kind of flipping, you're jumping over that line. So it's going to flip over the x-axis, and now it's going to look like this. So when I say it's a reflection, more specifically, it's a reflection over the x-axis. And then I have a fraction. What does a fraction do to the graph?
Compresses it.
That's going to be a vertical compression. Good. So my final answer
B.
is B. So even if you know what it's going to look like, you also have to know the actual vocabulary words, okay? Because a lot of you guys probably could figure it out if you had an actual picture, but it's more important also to understand the words themselves. Okay, so negative sign is a reflection over the x-axis. And then when you have a fraction, that's a vertical compression. What would make it a vertical stretch? What type of number?
A number that is greater than 1.
Greater than 1. So if it was like -5, -6, -4, that would be a vertical stretch. But since I had -1/4, that's a vertical compression. Any questions on this one? So those are kind of, that's kind of a review of the different types of transformations, okay? You can go up and down by changing the value of K. You can go left and right by changing the value of H. And then you can flip or stretch, compress by changing the value of A. And again, I don't have time to reteach everything. So if this is something you're struggling with, I definitely want you to review a video tonight when you study. That's the best thing you can do, is go back and watch the video where I already taught it, just as a refresher. So any questions? All right. Okay, now here's a graph. Let's see who can get this one. Which of the following graphs has a minimum point at the line x equals 4? Go ahead and try this one out. Okay, we're about halfway there. Ten more seconds remaining. 5, 4, 3, 2, and 1. All right. So this is exactly what I expected. We have kind of between, a lot of people chose A, a lot of people kind of chose C. That's what I thought would happen. I thought people would be between A and C. And then I had a few people choosing D as well. So there's kind of a lot to just make sure we understand about this problem. Let's take a look. First of all, I'm looking for a minimum point. Remember, the minimum of a graph is the tippity bottom, not the tippity top. So look at the vertex of each of these graphs. Which of these is a minimum and which of these has a maximum?
B and D are out.
B and D are out because these are maximum points. Yeah. Those are maximum points, but we need a minimum point. So B and D are automatically out. And then it's telling me to look at the line x equals 4. So x equals 4, we look at the x value. Here's x equals 4 on this graph, and here's x equals 4 on that graph. Which one has the minimum point at x equals 4? A or C?
C.
C.
C, yeah.
A, if the question were to ask the point at line y equals 4, then you'll choose A, but it's asking x.
That's exactly right. I was just going to say that. So for A, the minimum value is at y equals 4. Okay, but for C, the minimum is at x equals 4. And in this case, that's y equals 3. So you had to read this one super, super carefully. This one was a question that there's a very similar one on the test. It's not the same exact question, but it's pretty similar. So just make sure with something like this, you read things super carefully. It was asking for a minimum point, and it was asking for x equals 4, not y equals 4. So you had to be it was a little bit tricky. Questions on this one? So I'm seeing a couple of people in the chat telling me that they sometimes get confused about like maximum and minimum and which one is which. So I think the best way to think about it in my experience is to literally think about, on one hand, you might have a hill. Like, you're climbing up a hill. If you're climbing up the hill and you get to the tippity top, that's your maximum. Now, on the other hand, let's say you're climbing down to the valley of a hill. If you're going down, that's your minimum because you get to the bottom. So always you can think of a hill, you can think of a roller coaster. That's also a really helpful way to do it. You only have one or the other. You might be at the tippity top of a hill, or you might be at the tippity bottom of a valley. Okay, so if that kind of helps you as well to think about, that's another good way to do it. Or a roller coaster as well. Are you at the top of the roller coaster, or are you at the bottom of the roller coaster? So any other questions on maximum, on minimum, or any other part of this problem? Cool. All right. Next up, another graph. Okay, this one's a little bit trickier, so I'm not going to do a poll. I kind of want to do this one all together. So here it is. Which of the following equations represents the function graphed below? Now, take a look at these equations, these function equations. What form are they all written in?
Standard.
These are all in standard form. Good. And what does standard form tell you about the graph?
Y-intercept.
The y-intercept. So it tells us the y-intercept. It actually will tell us one more hint, but I'll talk about that afterwards. So all of these are my y-intercept. Which of these is automatically out?
A.
Good. A is out because the y-intercept, we can look on the graph and I can see that the y-intercept is right here on the -4. So automatically A is out. Is anything else at this point out?
C.
Why?
Because C is stating that the graph is reflected, which it is not.
Good. So that's the other hint that I was talking about. Standard form also tells you about the direction of the graph. And since this has a minus sign, what does that minus sign tell me? This negative sign?
Is reflected.
It's a reflected graph. Now, the actual graph I have is not reflected. It's totally normal. It's facing upwards. So for that reason, C would also be out. So reflection is when you have downwards, a downwards facing graph. So A is out because it has the wrong y-intercept, and C is out because it has the wrong direction. But now I'm stuck between B and D. Is there any other clue just from looking at the equation, or am I going to have to do a little bit of work?
Gonna have to do more.
Yeah. So I have these two equations. What can I find out about the equations by doing a little bit of math?
Vertex.
We can find the vertex. Now, looking at my graph, let's do a little approximation of where this vertex is located. Approximately. What does that look like?
It looks like something, a decimal for the x,
Mm-hmm.
a decimal for the y.
Yeah, so can we try to pick a good estimate?
1.5,
Mhm.
because middle of 1 and 2.
Mhm.
6.5.
Yeah, that's what I would have guessed too. So that's a pretty good estimate of the vertex. Well, now we can see which of these matches that number. So I'm going to go ahead and calculate my vertex. Now, who can remind me, how do I do that? Oh, my bad. Okay, while this loads, how do I calculate the vertex on a standard form equation?
Vertex formula.
The vertex formula, good. So there's a formula, right? We got the vertex formula. And I can use the vertex formula and check which of those answers is going to be correct. Now, let's see if I have a space to do it. Yeah, I'll do it up here. All right. So let's check B first. So B is not negative, is x squared minus 3x minus 4. All right, what is my vertex formula again?
Vertex formula?
Mhm.
H equals negative B divided by 2 parentheses A.
Good. Now in answer choice B, what's my A?
1.
What's my B?
Negative 3.
And then we already know C is negative 4. All right, so now I just go ahead and I plug those numbers in. So negative 3 over 2 times positive 1. So I have a double negative. What does that turn into?
Positive.
Positive. So I have positive 3 over 2. What's 3 divided by 2? Three divided by 2
3 divided by 2 is 1.5.
is 1.5. All right, so I have my H values. So far, am I good or am I bad? Does this match so far?
What's next?
So my question is this answer choice so far, is it good to go or is it wrong?
We don't know yet.
But we know the H value. Does the H value match so
Yes.
far? Yeah, the H value, remember that the vertex is H comma K. So far I have the correct value for H. Now I just have to check to see if I get the correct value for K. So how do I find out K? After you find out H, how do you get K?
You plug it in.
You're going to plug it in. So I'm finding F of 1.5. I'm plugging in 1.5 into where I see my X's. And for this, oops, that's not what I wanted. Can I make this bigger without stretching it? I guess not. Okay, but for this, you can definitely use your calculators, okay? So go ahead and take a moment. We're gonna do 1.5 squared, see what you get. Multiply 3 times 1.5, and then we're gonna add everything together. So what do I get for 1.5 to the power of 2?
Put that in the chat.
Yeah, you can put it in the chat.
Wait, public or private?
Private's good. I want to see how many people can get it right. What's 1.5 to the power of 2? Put it in the chat in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, I'm seeing a few correct answers. 1.5 squared is 2.25. What about 3 times 1.5? Three times 1.5. What do I get there? Good, 4.5. Good. And now we just put it all in the calculator. 2.25 minus 4.5 minus 4. What do I get? Final answer. There you go. Good. Bianca got it first. Negative 6.25. And that is my K value. So how do we feel about answer choice B? Should I circle it or no? Do we have a match? H comma K. I got 1.5 comma negative 6.25. Now we estimated when we chose these numbers, we were estimating. So it might not be perfect, but do we have a pretty good match?
Yes.
Yeah, we do. So B is good. As long as when you estimate it, obviously you're never gonna, when you're estimating something, you might not have the exact number. So we were just looking to make sure that the two answers we got were pretty close to 1.5 and negative 6.5. So B definitely works out. And if you try to do answer choice D, you would get a completely different number. So you can do it on your own if you want to get a little bit extra practice later when you study tonight. You can try out answer choice D to show that it does not match at all. Cool. Questions? Any questions on this whole problem? So here's the biggest takeaway with a problem like this one. Let's say that you have 5 minutes to get this problem done, and then that's it, and the test is over. If you don't have a lot of time, what is at least something you can do to increase your chances of getting it right?
Cross out the answers that you know will be wrong, and then go to the graph and see if you could eyeball it.
That's exactly what I would do. So answer choice A, definitely wrong. Answer choice C was definitely wrong. We didn't have to do any math to get those answers out. And then if you're only stuck between B and D, that's a much better chance of getting it right if you have to guess. 50-50. So that's the best strategy on multiple choice questions. Try to get it to a 50-50 chance. If you have to guess, make it a good guess. Make it a 50-50 rather than 25%. All right, any questions? Go ahead, Ajara.
He gave us half.
Could give you half, you get halfway there. All right, moving on. Now it's 10:35, we have 10 minutes left. We're almost there, but I want to pick the best out of the remaining questions. So actually this one's pretty good because there's a few questions like this on the test. So let's see how much we remember about this topic. Go ahead and try it out. 1 minute. And again, if this is something you don't remember, I just want you to make the best guess as possible, because I just want to see how everybody's feeling on this so far before we go over it.
Oh, I messed up.
Oh, alrighty, about 5 seconds. 4, 3, 2, 1. Time. All right. Okay. There was like, again, another situation where we're stuck between a few options. So we were kind of all over the place, but B and C were kind of the two that we were maybe guessing between. So let's take a look. Okay. So what are we looking for on this graph?
I forgot the name of the graph, but it was cubic something, right?
Yeah, it's a cubic function. That doesn't matter. You don't really need to know that, but it's good to know. But what am I looking for? When I look at this graph, what points am I looking at?
You're looking at the x.
Yeah. X-intercepts. What are those 3 x-intercepts?
-3, -2, and +1.
-3, -2, +1. Now, to pick the correct answer, what do you have to remember to do to these 3 numbers?
Flip it.
Flip the sign. So I'm looking for an answer that has +3, +2, and -1. Which ones am I down to?
A and C.
A and C. Exactly. So +3 over here, +2, and -1. That was the first part. You had to look for that. Okay, so do I have any questions on that part? Okay, now the second part of this is answer choice A has nothing in front, answer choice C has a negative in front. This is something that you actually don't need to know. So pausing here, okay, on the test that you guys are taking, they're not going to ask that. They're not going to make it this tricky. I'll just so you know, but I am going to explain which one it is. So with a cubic graph, you know how, okay, let me just show you an example. So parabolas, they can go upwards or they can go downwards, right? This would be a positive graph. And then this one would be a negative graph. The same thing happens when you have a cubic. So for cubic functions, it can go this way or it can go this way. What do you guys think? Is this one positive or negative?
Positive.
Yeah, this is positive. And this is negative. Again, you do not need to know this for your test, but it's kind of nice to understand. So what do I have in this case? Is this going in a positive direction or a negative direction?
Positive.
Yeah, this one is positive because it follows this sort of pattern. So it's not C, it's A. But again, on your test, that will not be part of the problem. Okay, so I kind of picked a trickier question than what's actually going to be on your test. But the most important thing is to remember to flip the sign of the x-intercepts. Okay, so that's why we ended up with -1, +2, and +3. Any questions on this problem? Now remember, these 3 binomials, those are called the factors. It has 3 factors, so it has 3 x-intercepts. All right, I have just enough time for one more. Let's see, these are long, so I'm just going to do this one. And then the 2 that we didn't get to, I'll post them on Teams so that you can study it tonight. So, okay, an architecture student is drawing a graph as shown below. The arch has the shape of a parabola that begins at the origin and has a vertex at 4.6, 12.2. And it's asking, other than the origin, at which point will the graph intersect the x-axis? Let's see really quick, do your best guess. I'll give you guys about a minute because we're close to out of time. Go ahead. All right, 15 seconds, pick your best guess. There's a few different ways to do this one. All right, 5, 4, 3, 2, 1. Okay, so let's see. Answer choice C was the winning answer. Let me show you. C was the or no, B was the winner, but C had also a few people. So let's check it out. Where is this going to touch the x-axis again? Because what's going to happen is this keeps going down, 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 and it's going to touch the x-axis. And if you eyeballed it, then you probably chose answer choice B, and that is correct. Okay, C doesn't make any sense because C is where the vertex is. It's not going to touch the x-axis at the vertex. So C doesn't make sense. 12 is way too far. And if you weren't sure between B and D, something that you could realize is that the vertex is the axis of symmetry. So this is cutting the parabola in half. So if this is 4.6 units, then this is also going to be 4.6 units. So you can do 4.6 plus 4.6, which gives you 9.2. So that was the other way to realize that it's 9.2. So any questions on this one? All right, looks like the bell rang just in time. So please make sure, guys, tonight you study, watch videos, review your notes, do these problems that I will post later today on Teams, and ask me any questions on Teams that you might have. This is your last topic test of the whole school year, so make it count. Make it your best one, all right? I'll see you all tomorrow. Bye, everyone.
See you tomorrow, Ms. Lopez. Have a nice day.
Thank you, you too.
Ms. Lopez,
Yes, Chloe.
what were the days for the testing?
Tomorrow and Wednesday. And then if you don't, oh, for the EOC?
Yes.
Here you go. May 26th and 27th.
Okay, thank you.
You're welcome. All right, bye, everybody.